Welcome to Lesson 10. This will be the last lesson before the mid-module assessment, and we're going to talk about sequences of rigid motions, which we have been doing. We did reflections and translations together, and we've done rotations. We've sequenced rotations around the same center and rotations around different center of rotation. And now we can sequence all three. And so we're going to be describing those sequences, and our focus is going to be on using precise language and being specific about what the transformations will look like. So our first example combines all three types of rigid motions that we've talked about. And let's read it. You don't have this in your classwork, so we can read it together. So it says to let transformation 1, or let translation 1, right here, be the translation along vector v, which is right here, from 1, 0 to negative 1, 1. Let rotation 2 be the 90-degree rotation around negative 1, 1. So we're going to use the endpoint of the vector as our center of rotation. And let reflection 3 be the reflection across line L, joining negative 3, 0 and 0, 3. So there's our line of rotation. So we're asked, what is translation 1 followed by rotation 2e and reflection 3e. Okay, so let's, I'm going to look at this a little bigger. So the question would be, does the order make a difference? What transformation do we perform first? The translation along the vector, the reflection, or the rotation? And I think we know from past lessons that the order is going to make a difference in this case. And so we would want to do it in the order that was stated in the description. And so we would want to do the translation first. And so if we translate our figure E here along this vector, we're going to move every point like so, and we should end up with the ellipse up there. So let's look what that would look like in the first step. I have it precisely drawn here. So there's our, oops, cancel. Sorry, let's get the right picture on here. Here we have the image E1 of our figure E under this translation vector. So now we have been told that the second transformation is the rotation around center negative 1, 1. And so here's our center of rotation. And I'm not using my overhead, obviously. So if we want a 90-degree rotation, that figure is going to come down around here somewhere. So let's look at what that looks like. And there we go. So here was our first transformation, E1. And then the rotated image of E1 came down there. And now the last thing to do is to reflect it. So we want to reflect it across line L. So we're going to get this mirror image, and it should be something like that. If I had my transparency, I could do it exactly, but it's going to be something right around there. So let's get the next picture here. And so this sequence of transformations, done one after the other, gave me this final image, E3. So E3 is the translation. Let's see, the translation followed by the rotation, followed by the reflection. All right, now we're going to look at some of your exercises that are in your notes. So let's look at exercise 1 together. So we'll read it. In the following picture, the triangle ABC can be traced onto a transparency and mapped onto triangle A prime, B prime, C prime. Which basic rigid motion or sequence of would map one triangle onto the other? Okay, so you can see from this example, just think about it quickly. What rigid motion would map those onto one another? And if you said reflection, you're correct. But we need a little more detail than just that. We could say a clearer answer would be to say reflect over, and we'll call it line BC, the line containing the points B and C. So we want to reflect over line BC, and that would map them together. And the reason that it will map them together, and you can use a transparency to prove it, is that because these two angle B's are the same angle measure, this ray and this ray will then map on top of one another, and these two rays will map on top of one another, and they're going to meet at that point A. So the points B and C of our triangle, what we're trying to do is get all A, B, and C to match up with A prime, B prime, C prime. Well, we can see that B and C are definitely going to match up because they're on the line of reflection, so they won't move. So we're just left to show that A and A prime will match up. And we do that by knowing that these angles here are the same as these here, and therefore their rays will cross. Okay? But this is specific enough language for you to use. If you're going to tell me it's a reflection, tell me the line of reflection. Okay, so let's look at 2 quickly. Look at that and think about which rigid motion would map those together. Okay, so hopefully you saw that rotation in this case will do the trick. So it is a rotation, but how can we be more specific about this rotation? Well, we would need to tell a couple things. So we could say it's a rotation around or about B. And B prime, of course, are the same point in this diagram. So we're going to rotate around B, and we're going to rotate D degrees, where D is equal to the measure of angle C, B, C prime. So that's the amount that we need to rotate. Once we do that, I can see that C prime will map to C, and A prime will map to A. Another detail we could give about this rotation is that it is the direction of the rotation, that it's counterclockwise. Counterclockwise around B, and that the counterclockwise rotation, which would be positive, right, would be this measure of this angle. So, okay. Okay, here's another diagram to look at. And look at this one, and it's the same. We're told triangle ABC can be traced on transparency and mapped to A prime, B prime, C prime, which basic rigid motion or sequence of would map one triangle onto the other. Okay. In this case, we could, so hopefully you have thought about this, I think we could probably find a line of rotation out here somewhere that would map those two triangles together. However, it's hard to describe that line. So while it exists, it's easier to use a sequence of rotations. It's easier to describe that. So if you saw that we could do a rotation, and then a reflection, you saw this sequence. And so, but what more detail do we need? We do need a little more detail than that. So we could say something to the point of this. Let me erase what I have. We want to rotate what? We need a center in degrees. So rotate around center B, D degrees, and angle D, and what is the direction of our rotation? We're mapping, in this case, would map one triangle onto the other. Okay, so we're going to take the prime and map it on there. So what direction? This would be a counterclockwise direction. But D is equal to the measure of angle CBC prime. And it would be counterclockwise. Okay, so we need to rotate, and then you can see that I'm back to the situation of exercise 1, where I've got B, C, and B prime, C prime completely lined up because I've closed this gap. So those are lined up, and I'm going to reflect over the line containing BC. So we're going to rotate around point center B, D degrees, counterclockwise, and then reflect over line BC. Okay, so now we're in exercise 4, and these triangles are completely separated from one another, no points in common. So we need to map each vertice of the triangle onto the other. And so let's read what is given in this problem. We're told that the triangle ABC can be traced on a transparency and mapped to A prime, B prime, C prime. Which rigid motion or sequence of would map one triangle onto the other? So once again, so we've got two scenarios here, two different problems. Once again, our ultimate goal is to have every vertex matched to its corresponding vertex. And so we really want to start by just matching one of those, one pair of those. So you really have your choice. You could, and so that would be a translation. I'm going to either translate by vector B prime B, which would be right here. There's a vector I could translate along. I could translate along A prime A, right here, A prime A, or I could translate along C prime C. So if you think in your head which of those you want to do, once you get them to that point, they're going to require other motions to be mapped together, probably a rotation. So I'm going to choose this one. I'm going to choose B prime B because it puts me in the position of one of the exercises I just did. Exercise 2, I think. So when I translate along this vector, I'm going to have B prime ends up coinciding with B, and then I've got the triangle coming down this way, A and C, like so. And so I'm back to exactly what was in exercise 2. Oh, this pen keeps not writing. And I need a rotation after that. So how would we precisely give those directions? Well, we would say and the order does matter, right? Let there be, well, I'm going to write it in shorthand. So we're going to translate, and I need to give the vector. So it's along B prime B. And then rotate around center B, D degrees, where D is equal to the measure of that angle CBC prime. Or another way I could say this is D degrees until B prime C prime coincides with BC. So I want to do that rotation until it gets there. Okay, so let's look at scenario 2. Okay, what do you see in scenario 2? If you want a chance to look at it before I talk, you can pause. But in scenario 2, I can see that if I translate along this vector, B prime B, it puts me in the situation of exercise 3, and I know how that would go. So I can translate along vector B prime B, and then I can, what do I do next? Next would be the rotation. Rotate around center B until B prime C prime and BC coincide, until B prime C prime coincides with BC. And then, so I translated, then I rotated, and then I'm still going to have to reflect. Finally, I will reflect across the line containing B, and C. And when I do that, I know that I'm going to have the triangles mapped onto one another perfectly. Okay, our final example are these sort of ice cream cone shaped figures, and we're told some things about these figures, that this angle B, it has the same measure at angle B prime, and angle B have the same measure of 80 degrees, and that segment, this curved segment, has the equal length of this curved segment, AC, and A prime, C prime. And we're given that these lines are the same measure. Okay, so it says, with clarity and precision, describe a sequence of rigid motions that would map figure ABC onto figure A prime, B prime, C prime. So pause the video, think about what you would do, how you would do that. Use your transparency to check your work to make sure that the sequence that you describe does do that. And then we'll try to describe it as clearly as possible. Okay, there are a couple different ways you can do this, but they're fairly similar. I would think of first let me erase what I have here. I would start with a translation to map point B to point B prime. So there's my vector. So I'm going to first translate along vector B, B prime. Because we're told to map ABC, so we're actually taking this figure and mapping it onto that figure. So if I once I translate along BB prime, I've moved figure ABC down so that B and B prime are the same point. And then what I'd like to do is rotate. I will rotate around center B prime or B. They're both the same point now. Rotate around center B until AB coincides with A prime, B prime. Okay, so we know that AB and A prime, B prime are the same length. So now I have not only mapped B to B prime, but we've also mapped A to A prime. So we're only left to get C onto C prime and make sure that the curved part of the figure matches up. So my last part, once I translated, I rotated. Now I'm going to reflect across line. In this case again, it's A prime, B prime, or AB. They're the same. Sorry for the gap there. they're the same length, and they're the same line now. They're mapped together. And so I want to reflect across line AB, so that C and C prime, C corresponds or coincides with C prime. Now I'm not told that those lengths, that this length matches this length. But because I'm told that these two lengths match, I can conclude that these sides, BC, I've got a mess here, but this is B, remember? BC and B prime, C prime are now coincide. So B prime, C prime coincides with BC. And the lengths are the same, so the curved segments will coincide. Therefore, my translation, rotation, and reflection mapped figure ABC onto A prime, B prime, C prime. Okay, so in the problem set, you're going to be doing slightly different types of problems, but they will all involve using precise language and describing sequences of rigid motions so that one figure maps onto another. So just to recap, you need to say more than translate. So in this example, tell me the vector. You need to say more than rotate. Rotate around a center, certain number of degrees. And when you say reflect, we need the line of reflection. So you need to plan, when you do these, we're planning our motions. Even though there's different ways we could do it, we want to plan so that we can tell what the line of reflection is or what the center of rotation or the vector will be. And that's the main idea here, is to do it. There are many different ways to do it, but you plan it so that you can describe it accurately. Okay, good luck on the problem set, and we will be ready for the mid-module assessment after you've done this lesson.